All right, so we've been looking at solving systems of equations, linear equations specifically, and we've used a graphing method. Yesterday we looked at, and the day before on the video, we looked at the substitution method. Today I'm going to teach you a third method called the addition method. Some teachers do call this the elimination method. Some teachers and some textbooks get a little bit more precise and call it the linear combinations method. I really don't care what method you call it, but I will tell you that typically I call it the addition method due to the fact that that's what my Algebra 1 teacher and my Algebra 2 teacher called it. So you'll hear me say the addition method most of the time. So when we look at this, notice that this particular problem, you have 4x and 3y equals 16, 2x minus 3y equals 8. Neither one of these equations is going to be pretty to graph. They're not ridiculous, but they wouldn't be pretty. And neither one of these equations would work very well for things like our substitution method, where we picked a variable to solve for. Because if you look at those, there is not one particular variable that's easy to isolate, to get by itself. So we have another method. This is called the addition method. The addition method is used when we want to get a variable to cancel out instead of trying to solve for a particular variable first and substitute it into the other equation. That's why some teachers call this the elimination method, and we'll see that when we get into this process of step 3. There's also a reason why I call it the addition method, and my teachers before me called it that as well. So we're going to look at this, and we're going to go step by step. If you want to pause the video so you can copy down these steps, that's fine. You don't have to have the steps. They're not required in your notes. But if you want them, you can pause and copy these down. Excuse me. Step 1. We're going to arrange the equations with like terms in columns. We're about to take these two equations and add them together at some point. That's one of the reasons it's called the addition method by many teachers. So notice that I have my x terms lined up in a column. I have my y terms also lined up in a column. I'm trying to make this a little bit more vertical looking. And I also have my numbers lined up in a column. Technically also, something kind of to notice here is that our equal signs are also lined up. Essentially what we're doing is we're trying to get both of the equations to be the same form. This is called standard form of a linear equation. When you have the x term, the y term, and then the number term, that's called the standard form of a linear equation. So when you are looking at these particular equations, you're trying to get them to look the same. So I've got my x terms lined up, my y terms lined up, my number terms, even truly my equal signs are lined up here. If they are not lined up, we will make them line up. In other words, notice this 5x here is on the wrong side of the equal sign. We can move it to the other side over here. Not just plopping it over on the other side, but adding 5x. Remember, when you go from one side of the equation to the other side of the equation, you have to make sure that you actually do the opposite. We've done this numerous times before. This won't be something new. We're just moving 5x from one side to the other. So we're going to look at that here in just a little bit. We'll come back to this particular problem. But so step number 1 says line them up. Step number 2 says multiply one or both of the equations. Notice it says one or both. You don't have to do both. You actually don't even have to do one, because what you're trying to do is get one of them to be opposites. And this is the absolute critical step to this whole method. You have to multiply one of the equations or possibly both of the equations to get opposites for one of the variables. Notice on this first one that Mr. Harrison gave us, we've got positive 3y and negative 3y. Those are opposites of each other. So we are going to go ahead and say, oh, look, step number 2 is already done. These are opposites. 3y negative 3y. So, step number 3 says, once you've got opposites for one of the variables, you're going to add the equations together from step 2. Combining like terms is going to eliminate one of the variables. This is why, again, some teachers call this the elimination method, because what we are going to see happen is we are going to see one of the variables cancel out. And of course, the pen's being real nice to me. So watch what happens on this example that I have over here. Remember, I lined them up first. Then I looked and I realized I've got positive 3y, negative 3y. Those are opposites of each other. I'm going to add these two equations together. This is again why I call it the addition method. What is 4x plus 2x? That's right, 6x. What is 3y and negative 3y? That's right, it cancels. What is 16 plus 8? 24. So look at what happens. One of the variables cancels out. It's gone. That means what you have now is a very simple equation, 6x equals 24. And I mean that. I'm not trying to make anybody feel stupid, but that should be a very easy equation to solve. If it's not, there's a possibility you maybe shouldn't be in algebra 2. I know that was mean of me to say. You're mean, Mr. Harrison. Okay, but seriously, you have 6x times 20. I can't talk. Maybe I shouldn't be in algebra 2, right? I have 6x equals 24 if I want to get x by itself. Simple little division to get rid of the 6. 24 divided by 6, take out my calculator, it's 4. Now this is where the process gets more difficult. Because once you've got this answer, step number 4 says, substitute the value from step 3 into either one of the original equations. Wait a minute, Mr. Harrison. I recognize that word, substitute. Does that mean I just basically go back and do the same thing we did with the substitution method? I just plug it back in up at the top somewhere and then I get my answer for my other variable? Basically, yes. Now, like I said, it does get a little more difficult here because this is not as simple as 6x equals 24. So you have to take this and plug it back into one of the top equations. I would probably plug it into the first one on this one. So that would give me 4 times x. So I'll plug in 4 where the x is, because that's what x is equal to. Then I have plus 3y equals 16. So again, essentially you're getting down to the substitution method here. 4 times 4 is 16. Then if I want to get that, remove it to the other side over here. I have minus 16 to get rid of it. Same thing on the other side. That gives me 3y equals 0. If I divide by 3 there, that's still going to be y equals 0. That's interesting. That means my y value is nothing? Absolutely. That's exactly what it means. Guys, you can have a y value that is nothing. That doesn't mean that it's no solution. My x was 4. My y is 0. That just means that's the answer to the problem. That is the point where those two graphs would intersect each other if we're going back to that whole concept that we've been talking about the whole chapter of finding the point that works for both equations. They would both touch 4, 0. So there's my answer. Guess what? If you did the substitution method, you get the same answer. If you did the graphing method, you get the same answer. So you have ways to check yourself as well if you need to, which is what step number 5 says. You can check your solution. You can plug that number in and see if 4 and 0 give me 16. 4 and 0 give me 8. So this method is called the addition method. Again, some teachers call it the elimination method because the whole goal here is to get one of the variables to cancel out, like this positive 3y, negative 3y cancels out. Well, Mr. Harrison, okay, that's cool. But you made that one happen. You're exactly right. I made that 3y, negative 3y for you on this problem. But on this problem I did. Take a look at this one. You've got 5x, 2x on the bottom, negative 4y, 8y on the bottom, and then you have your equal signs lined up and your 3 and negative 2. Again, by the way, if you want to try this on your own, pause it first before I go through it. But notice my x's are lined up, my y's are lined up, my numbers are lined up, even my equal signs are lined up. That's what step number 1 in the addition method says. Line it all up. So now we are going to get opposites. Now some of you, there might be 1 or 2 of you, maybe a lot more of you, that says, oh, yep, we already got them. We got negative 4, we got positive 8. Those are opposites. No, they're not. Negative 4 and positive 8, these will not cancel. That's negative 4, positive 8. There's still going to be something left. Opposites means this would have to be a negative 8 and a positive 8. Oh, listen to what you just said. A negative 8 and a positive 8 would cancel, wouldn't they? Step number 2 over here on the steps for solving with the addition method says we multiply one or both of the equations by a number so that you have coefficients that are opposites. Now this is essentially just a polite way of saying make them be opposite. Force them to be opposite. This is not some kind of magical mathematical trick Mr. Harrison's pulling. I'm not going to go through and I'm going to say, oh, look guys, I'm going to show you a formula later. No, there's no formula here. You are forcing negative 4 to be 8 by multiplying this top equation by 2. Well, Mr. Harrison, why do you do the whole equation? Why the whole thing? Because if you take one side and multiply it by 2, you got to multiply the other side by 2. Remember, that's that whole what you do to one side, you got to do the other, right? So when you multiply this by 2, 2 times 5x would be 10x. And let me save a little bit of space here. I'm going to come down right below it. Oh, goodness. 2 times negative 4y would be negative 8y. And then 2 times 3 would be 6. That's a very common mistake. Watch out and make sure you multiply that number by 2 also. But now look at what you got. You've got an equation now where you took the first equation, you doubled it. That's not going to change the answer because you doubled the whole thing. That means you actually kept the same answers. You just doubled all the numbers in the problem, not the actual solutions. And then now you have negative 8 and positive 8. So you take this and you add them together. What is 2x plus 10x? Good, 12x. 8y and negative 8y. They cancel out. Negative 2, positive 6 is 4. Now this one is a little bit uglier, slightly uglier here. You got divide by 12 there and you end up with 4 over 12 or 1/3 as a fraction. If you don't know how to go through and actually divide those, take out your calculator, pull out Desmos or a graphing calculator. If you've got one of those graphing calculators, you take 4 divided by 12. When you take 4 divided by 12, it's going to give you 0.3 repeated, right? Press the little fraction button or math, enter on the other calculators, and it tells you 1/3. I apologize for the sound of the emails coming in there, if you heard that. So, x equals 1/3. So, now, basically you turn this back into the substitution method. You could go all the way back to your first equation if you wanted to. You could come to your new first equation if you wanted to. Or you could take this and plug it into the second equation. That's the one that I personally would plug it into. 2 times 1/3 plus 8y equals negative 2. But it's up to you if you want to go through and you want to plug it into one of the others. That's fine. The good news about this particular method is once you get one of the answers, it really doesn't matter which equation that you plug it into at the top up there as long as you go through and you actually just solve it for the y or the other variable. So what is 2 times 1/3? Well, that is 2/3. Again, you can do that on a calculator, but I'm just doing that one kind of quickly in my head. The one that I will show you on the calculator is when you subtract 2/3 on both sides. It does cancel out here, leaves me with 8y. And then negative 2 minus 2/3, I go to my calculator and I say, okay, negative 2 minus, now I put 2 divided by 3, that's 2/3, Gives me this ugly decimal. I press that little fraction button. Whoops. And it gives me negative 8/3. Move my little head out of the way here. I don't know if that even changes on your screen. I hope it does. Now I divide by 8. And then y is going to be equal to negative 8/3 divided by negative 8/3 divided by, and we want to get it divide the whole thing, so let's put parentheses there. Whoops. Struggle bus, right? Divided by 8. It gives me negative 0.3. Press my little fraction button. Negative 1/3. This, again, is one of those reasons we want to have another method other than graphing. This would suck, graphing, because you would not find out that you couldn't even tell where that little point is at 1/3 and negative 1/3. But it also would be pretty bad with the substitution method, because this would be something that ends up being pretty ugly. I mean, already right over here we had to do some substitution anyways with this red over here. So my suggestion is to go through and be able to use this addition method. All right, so let's talk about what happens when you can't line them up. Or you have to get them lined up is a better way to say it. So if they're not lined up, by the way, pause it if you want to try it. When they're not lined up, we need to move this 5x over here. But we can't just randomly plop it on the other side. So guys, you got to remember, it's not about just picking up pieces of math and putting them somewhere. You have to actually add the 5x, because we got to do this, add 5x. What is it doing? Oh my goodness. Add 5x on this side and add 5x on this side. If I add 5x on both sides, what we are going to end up having happen there is I'm going to get a positive 5x on this side with the positive 2y. Then I can make it basically look exactly like the original, or I should say the first equation up there. Now, see, again, if you want to pause and try from here, now see if you can make one of the variables be opposite. Make one of the variables cancel out. You'll notice, hopefully, on this one that the y's would be great. All I'd have to do is make the 2 negative. So all you really have to do there is multiply by a negative. Or if you want to get a little more specific, it's negative 1 that I'm multiplying by. That gives me negative 3x, negative 2y, and negative 8. Then I can do my addition method. Now, so notice, I'm going to stop here for just a second. Notice you got equations over here. You've got equations over here that you moved the 5x, right? And then you're going to multiply by a negative, so you got another equation here. This requires organization skills, and this is one of those things I try to use different colors and stuff here and there on the screen. You won't be able to do that. Just make sure that you don't have, make sure your arrows, if you're going from one spot to another, are not too sloppy. And then double check yourself and make sure that if you write an 8 over here for 3x plus 2y, make sure when you move it to the other side, it's still 3x plus 2y and 8. Make sure that you haven't changed anything. When you multiply by a negative, then yes, you're going to change those numbers. So just make sure you're paying attention to what numbers you actually have. All right, so let's finish this out. 5x and negative 3x is 2x. The y's cancel out. 12 and negative 8 is 4. You get 2x equals 4, divide by 2, and that gives me x is equal to 2. Again, now I can take this and I can plug it in to find y. I suggest going all the way back here to the original, because that gives me an easy place to plug in 2 for x and get y. It doesn't mean it's the easiest, and it doesn't mean it's the one that you have to use. You can decide. It's up to you. So then you just solve this. Again, pause if you want to. 12 minus 10 here, because 5 times 2 is 10. That gives me 2y equals 2. Divide by 2 here, and that will give me y is equal to 1. Again, x is 2, y is 1. If you go through and you plug those points in, or those numbers for that point in, you will get both of those equations to work. That's the whole point of the process. The solution is what point is on both lines. So, here is one for you to try on your own if you would like. I'm going to pause the video myself, and I'm going to put the answer. So if you want to try it, better pause the video now, because I'm just going to pop the answer up on the board, on the screen, I should say. And then I'm going to move on to the next one to explain. So the solution is 2, -3. Notice on this one, right here at the very beginning, my x's will cancel out immediately. And so I can just go ahead and straight add those together. 2y and 8, 6y is 8y, divide by the 8, and I get -3. Plug that in to one of these equations. I chose the second equation right here. 6 times -3 is -18. Add it to the -16, and I get 2. All right, now here's another one for you to try. Again, I'm going to pause this, but I am going to do a little bit more detailed explanation on this one. Hopefully you were able to get that one really quick and start play again, but here what you look at is I want to cancel out the x's. If I cancel out the x's, I would multiply that top equation by 3 to get -3x and +3x. Guys, listen, notice I was focusing in on the x. I was not looking at the y. I was looking at the x. I multiplied by 3 to get this to be -3 so it'll cancel out. Again, the whole goal is that you make one of the variables cancel out. You force it to happen. This is not, again, some kind of magical math process. What is amazing, yes, I know I'm a nerd. What's amazing about this one is that the 3 times the y also gives me an opposite for the y, because there's a -3y and a +3y. So this is going to cancel. This is going to cancel. But that's going to give me nothing. Mr. Harrison, there's nothing over there. You're right. 3 times 6 is 18, excuse me. And then I add that to 2 and I get 20. But 0 is not equal to 20, Mr. Harrison. That's stupid. You're right. So what does that tell you about these two lines? What does that tell you about these? Oh! That means that these two lines, because the x's and y's disappear, you can't tell me x equals, you can't tell me y equals, because there's nothing there that says x equals or y equals, right? All you can tell me is that these two are not equal to each other when they cancel out. That means the slopes would be the same, but their y-intercepts are different. Or in other words, no solution. Because what that means is that you have two lines that are parallel. I know those are my real pretty parallel lines, right? All right. Now, what would it look like if it was infinite solutions? Well, if you had the same line like we did the other day in class, the same line would cancel out completely, meaning you would have 0 equals 0. You would not have 0 equals 20. That means they're not the same line, but they do have the same slope. 0 equals 0 would mean they're the exact same line. Everything's the same. And so they would cancel out. If you made them be opposite, they would be opposite of each other completely. If they're the same line to start with, you opposite one of them, or make it be opposite, it's going to cancel out completely. And so what that gives me is that gives me a line that would be 0 equals 0. That would be the ones that have infinite solution or the same line. So guys, you have the same 3 possible answers that we had before. You can get a point, or you can get no solution if they're parallel, or you can get infinite if they're the same line. All right, I got one more thing I'm going to show you. This is going to take me a second here. Just real quick. Is this the one? I do want you to be careful on this one. Just watch out, because it does look like the x's and y's are lined up. But please pay attention on ones like this. You don't have to do this one, but right here and right here. Notice my equal signs are not lined up. You need to move the 6y over, or you need to take this 3y right here, move it over to the other side here. Just be careful when you're lining things up. The one that I wanted to show you is here. And we'll try to keep this. I would like to do a word problem too, but we may save the word problem for class tomorrow. That sounds good. We'll do an application in class tomorrow. So, take a look at this example. Notice that on this one, number one, it's kind of weird because you got the X's and Y's lined up, but there's zeros over here. That kind of looks weird. And then the numbers are just kind of bigger numbers, sort of. That's just kind of ugly. Guys, if you run across something like this, the key step, like I said, is that step number 2 that says, all right, I'm going to multiply one of the equations or both of the equations to get opposites. Notice you can multiply both of them by a number. And notice it says that I'm getting opposites. I am forcing this to happen. So in other words, if I go back to that sheet over here, oh goodness, and I look at this little guy here, I could multiply 3 times the top one. Oh, dummy. 4 times the top one. And that would give me negative 36x positive 24y equal to nothing. But then in order to get opposites for one of the variables, doesn't matter which one, let's say I want to do the bottom one, I need a positive 36, so I'd have to multiply by negative 3. Oh, wait. Mr. Harrison, you mean you can multiply by just different numbers? Yeah, as long as you're multiplying one side of the equation by the same number on the other side, you don't have to multiply both equations by the same thing. You are forcing one of the variables to be opposite, which would make this right here a positive 36x, a negative 24y equals 0. Now notice this one cancels out everything. This would be one of those, that's that infinite solutions. Okie dokie. Now, you could also go back and let me see here. Let me see if I can do this in an easy way here. Let's duplicate the page. Yep. Hey, there we go. Mr. Harrison getting fancy with the math stuff here. That technology. If only I could get the board to work the same way I can get some of the fancy technology to work, right? This would be very simple with it. All right. So let's say, switch it up a little bit. Let's say I looked at the 6 and the 8, and I decided to multiply the 8 times 6 on the top. That'd be negative 72x positive 48y equals 0. Well, how would I get this to be a negative 48? Again, you'd have to multiply by negative 6 times that. Well, negative 6 times negative 12 is positive 72. Negative 6 times 8 is negative 48y. Negative 6 times 0 is 0. Guys, but notice I was focusing in on the y's. I didn't care about the x's. I am just making one of the variables cancel. This one just happens to cancel both of them. But even if I got to a problem like this guy over here, and I wanted to cancel out the x's, I was just, I was just so heck bent on it. I'm going to cancel out the x's. I'm going to do it. That's fine. As long as you make them be opposite. You can get one of the variables to cancel out, and it works for this method that we call the addition method. So I'm going to review it again. Step number 1, line up your equations. Make sure that you line up your x's, line up your y's, line up your numbers. Multiply one of the equations or both of them if you need to make one of the variables be opposite. Cancel those variables out. Once you cancel those variables out, you have a simple equation with one variable, solve it, and then plug that answer back in, find the other answer. So this is called the addition method. Again, and I don't know, oh man, this thing's gotten all messed up now. If you want to write down the steps, you can. If you've got any major questions, come see me. Otherwise, we'll be practicing this together in class tomorrow. We'll do a little bit of a word problem too, make you think a little bit more tomorrow. Maybe we'll do a little bit of group work with a word problem tomorrow, make you, give you a little bit of help. Okay? Have a great day, guys.